Happy New Year, folks. Oh, look like Jeff is still recovering from the holiday break.
Happy New Year, Sheldon.
You guys.
Can you guys hear me okay?
Yeah.
Yeah.
Okay, good. I was having a audio moment there for a second.
We'll have a smaller crowd.
Yeah.
You might remember Carol, Rajesh are deep in the water for NSF review.
Yeah, and I guess Mohan also has a conflict, so he might not be here.
Well, we have a newcomer. Maybe.
Yeah, have Jingu introduce yourself, maybe?
Okay, hello everyone. This is Gino Park. So I just graduated from Texas A&M, and I joined at UIUC as a postdoc under Shaowen. Nice to meet you all.
Hey, welcome.
Thank you.
And I guess for iGuide, Jingu is kind of helping us with me, Shaowen, and Diana with the project management. So you would also kind of get emails from him. Okay.
Another one.
Yeah.
Another one herding cats.
Yeah. Okay, let's see. So I guess as Shaowen said, today we'll have a smaller crowd since Carol and her team are dealing with an NSF review. But today we'll be looking at Hydroshare. So Jeff and Tony have prepared a presentation on Hydroshare and how kind of the capabilities of a Hydroshare, which could potentially be of interest for iGuide. So that's one of the things that we will do today. The other thing I guess I wanted to touch base on with everyone was kind of our to-dos for this quarter, just to make sure everyone is on the same page. So give me a second. I'll share my screen quickly first, then we'll go from there. Can you see my screen?
Yes.
Okay, thank you. So this is in our iGuide folder. So under management and coordination, we have the plan which was submitted to NSF. This is kind of the final plan. We have our team's plan as well. So if you go there for the milestones for this quarter for our team, I think there it is. So year one, quarter two. So these are the major milestones that we have for our team. I think these are modest, so we'll probably be able to, potentially we should be able to beat them. But the main thing that we need to do is, I guess, develop our plan for our platform, the iGuide platform, the roadmap, and kind of try to create an initial design, as well as kind of the user persona work that we started with Josh leading. So those are kind of the two major threads. And then, of course, we have the how do we collaborate within our team and across our team. So that's kind of the first two things, the platform as well as the user persona. So these are kind of the main things for this quarter, in addition to our sharing. So one of the main focuses of this quarter would be to moving ourselves into kind of creating these capabilities or creating these designs, as well as develop our roadmap. So more going from understanding of our each other's technologies to actually how do we implement, how do we go forward to integrate and implement together. So just wanted to, I guess, share that to refresh people's minds before we do the deep dive. So any questions on that? Okay, hearing none, I guess maybe we can go to then today's topic and give the floor to Jeff and Tony. And Jeff and Tony, this is recorded, so if others are missing, they can potentially watch it. I hope that is not a problem.
Okay. Will you enable screen sharing so I can share my slides?
Sorry about that. Yeah, go ahead.
Okay, thank you. Let's see, let me make sure I get the right one here. Okay, so hopefully you're seeing some PowerPoint slides.
Yes.
And let me make this, okay. All right, so Tony and I are gonna tag team this, and I will probably spend a few minutes here at the beginning, and then Tony's gonna take over a little nearer the end, but feel free to interrupt us as we go if you have questions along the way. We're happy to answer whatever questions that you've got. So just so everybody knows, Tony and I are talking today, but we're representing a much larger team of collaborators that have been working on the stuff that we're going to talk about today. So I don't want to steal anyone's thunder here. Okay, just a couple of introductory slides here. So I think it's true that cyber infrastructure can help bridge digital divides. And what I've got on this slide, I think the toolbox for data science has gotten quite good recently, where there's a lot of tools out there that help us do all of the kinds of things that we need to do for data science. They provide the data management, visualization, analysis, all those sorts of things that we need to do. And we're even starting to see those tools packaged and distributed in a way that they're more accessible and they're easier to use. But I think our contention that we had in writing the proposal is that tools are advancing, but composability is still challenging. And I think that is still very much the case. So how do we connect existing tools and systems in ways that make it easier for us to do our jobs? And just an example of this. So it used to be that when we outfitted our students that we were hiring, we would buy them a big fat desktop computer and soup it up with memory and RAM and hard drive space, and they would do all of their work there, and it was sort of isolated, and it was hard to kind of reproduce the environment that they were working on in their computer. But now much more services are cloud-based. And the real challenge now is, okay, so we've got somebody who's working with Hydroshare as a repository. They want to use compute resources via some sort of high performance computing resource. They're getting data from organizations like the USGS or other repositories. Maybe they're dealing with a lot of stuff, so they got to put it all somewhere, and they're using some Amazon storage. And then, of course, they want to make their analysis and visualization accessible, so they're putting all of that in some sort of Jupyter environment. And the issue is, like, not only do they have to figure out how to use each one of those environments, they have to make all of the connections between all of the environments too. And that is really quite challenging for anybody to learn how to navigate. So just a quick summary of some of those composability challenges, and then I'll talk about how we're addressing some of those with Hydroshare. So good cyber infrastructure components exist. We've got the parts, but how to connect them together. We need, I think, standardized interfaces between systems. So web service APIs, client code libraries for popular languages that makes it easier for us to work with these systems. And then, of course, we have to move things around. So in a lot of cases, we need some standardized packaging and representation of data and computational workflows for transport. And that includes data, metadata, and provenance information. And it would be great if we could develop these architectures such that they're transparent to users, because, you know, for example, we use Google Docs all of the time. We don't care about the how and the where. We just care that there's a document there that everybody's looking at and can edit. So can environmental data science be this transparent? And I think we need to continue thinking about and supporting the changes in the way people are working, because it's kind of developing pretty rapidly right now, with services being developed over the web and delivered over the web, and being able to string these pieces together to compose the types of analyses that we need to do. Okay, so also one thing that I want to throw in here is that reproducibility of all of this is also key. So building trust in our research requires transparency and reproducibility. And there's some ideas here coming out of John Goodall's group, who has worked on Hydroshare and other systems. They've done some work to define what reproducibility means in terms of computational workflows and how cyber infrastructure can help with that. So there's a couple of papers here that are worth looking at in terms of reproducibility and in particular modeling workflows. All right, so now to Hydroshare. So some of our goals. We want to enable water data scientists to more easily share and collaborate around data and analyses. We want to provide the data management, visualization, and analysis tools that advance water data scientists' capabilities and promote more consistent data workflows, data reuse, and reproducibility of scientific results. So those are some of the things that we're working on related to Hydroshare. And so just to demonstrate this in terms of a collaborative investigator workflow, so we want to easily create digital instances of data sets, or maybe even a whole data science workflow, quickly share that with colleagues, perhaps privately at first, because we're not ready for it to be, out on the streets and it's not ready for prime time. We need to iterate and work on it a little bit. So we want to add some value through that collaboration, annotation, and iteration. And then, of course, eventually we need to add some metadata to describe it. And then we want to share publicly or formally publish it. And when I say formally publish, I mean in a way that it's open, it has a digital object identifier, it's citable so that others can actually access it and reuse it. And so there's some questions here about what the role is of data repositories. And I'll say data repositories broadly, because Hydroshare is not just a data repository. And there are other repositories out there that have advanced functionality like Hydroshare. So what's the role of these repositories in this scientific workflow? So for any of you who don't know, and I think I'm probably preaching to the choir mostly on this call, Hydroshare is a web-based hydrologic information system and repository. It's operated by the Consortium of Universities for the Advancement of Hydrologic Science Incorporated, COASI. And it's really focused on creating and sharing data and models using a variety of file formats and flexible metadata. Hydroshare is effectively a repository for sharing and publication that uses FAIR principles. So just a few notes about audience and use. This slide's a little bit dated. I got it from Dave Tarbotton late last year. If any of you are interested, Tony can always give you more updated statistics here, but Hydroshare has about 10,000 users representing more than 200 US universities, about more than 250 international organizations. In Hydroshare, there's over 10,000 resources, and I'll talk about resources and what that means here in just a second. And on the order of about 600 plus active users per month. So these are the people who don't just have a user account, but are coming back and actually using the system regularly. So our primary audience is the US water science research community, because Hydroshare is funded through the National Science Foundation, but we don't constrain, it's not completely focused on that. It is open for other people to use internationally, and other water resource professionals, educators, and also some citizen scientists that use Hydroshare. Okay, so the concept of a resource in Hydroshare. So a resource is the primary unit of digital content. All the things that you can do with resources: create, version, copy, describe, own, share, access, discover, and eventually formal publication. All of that is done at the resource level. So you can think of a resource as a container into which you can put digital content, and that content can be a data set, it can be a data set and a model, it can be other types of research products that you want to share in the system. And in Hydroshare, resources have a file or a content-based definition. So when you go to the content area on the landing page for a resource, you see the file structure. You can put folders, you can organize things within a file hierarchy. You can have a README file. You can have all of your data files organized however you want. But every resource also has a semantic definition that's based on the Open Archives Initiative's Object Reuse and Exchange Standard, where a resource is an aggregation of files and a resource map actually defines all of the files that are aggregated within that resource, any relationships that exist among those files. And what that means is that humans can interpret the structure of a resource, but a machine can also interpret the structure of a resource as well through reading the resource map document and all of the accompanying metadata files that go with the resource. Okay, so what can you put in Hydroshare? It's pretty broad, water science related data and models. Any files can be uploaded. Hydroshare's resource data model is file based. So images, movies, model input files, data files, whatever you need. Hydroshare does have some value added functionality for some specific file types. So this list right here, time series, geospatial data sets, multi-dimensional file set, model program, model instance. Those are all known content types that we've defined as specific content type aggregations in Hydroshare. So if you upload those, Hydroshare does automated metadata extraction, automatic creation and hosting of web services. For example, if you upload a geospatial data set like a shapefile or a raster, Hydroshare automatically creates OGC compliant web map services for those using a GeoServer. And then also we have a suite of web apps that go with Hydroshare that know how to interact with some of that content. Okay, so more particularly in terms of data science, we think of a Hydroshare resource as something of a data science enabler. So when you're creating a reproducible data science workflow, you have to make some decisions about how you're going to organize all of your content. And if your eventual goal is to share the analysis with others, you got to be able to get all of that stuff, whatever it is, into a repository. And that could be data, it could be code. And you need straightforward ways to organize the content, potentially including model inputs, model outputs, code, whatever it happens to be. And so the Hydroshare resource can be a great organizing container. You could think of it as a project directory. It has an existing data model that's machine readable. It has a semantic representation of the structure. It's flexible. You can pretty much put whatever you want in there. And then we have these existing aggregation or content types to identify commonly used data. And I'll also talk about how the whole thing can actually be mapped to a Python object model for easy manipulation within a programming environment. And the last thing, it's already handled by a repository with Hydroshare. So that's all really great. Okay, so just to drill in a little bit further, connecting visualization and analysis with an online repository like Hydroshare, how do we better enable collaborative data science workflows and reproducibility? Well, here's one example. So a scientist working in their local Python environment might be downloading data from the United States Geological Survey's National Water Information System. This could be streamflow data or whatever data they're getting from NWIS. They want to do some specific visualization and analysis in their environment. They develop some Python code to do that. They generate a set of results, and then they want to be able to share those results in a way that somebody else can actually access them and redo what they've done. So they take their code and their data, they upload it to Hydroshare, and they can share it publicly. They can get a digital object identifier. People can discover things through Hydroshare. They can cite their data through their paper that they write about it, and then people can access it that way. And then somebody else working in their own local Python environment can access Hydroshare, download that content to their computer, and they can reproduce the specific results that are the same as the original researcher. Likewise, somebody who doesn't want to create a Python environment that matches whatever was used by the researcher might be able to download that same content to Hydroshare's linked Jupyter Hub Python environment, execute the code there, and get the same results to produce exactly the output that was produced by the original researcher, right? So there's some tools that we've created along the way to make these arrows work. I'll just mention the USGS data retrieval Python package. I'm not going to say much about that today. It's just a package that we've been working on to access data through the National Water Information System. It's similar to some other tools that are out there. I will talk about the Hydroshare client package because we use that to get data and information, metadata into and out of Hydroshare. And then when we're pulling data into that local Python environment, we can actually map all of the metadata and the data objects to objects in Python, which can then be manipulated in Python. And then we can use existing scientific Python packages like pandas, matplotlib, NumPy to basically represent the data objects and do whatever analyses we need to do once we get them into Python. Okay, so I've talked about these Python packages. Really, they're focused on enabling simple interactions with the data repositories, in this case, the USGS National Water Information System, and on the right, Hydroshare. And the real focus here is getting the data and getting it in the format that scientists need to actually do their analysis without spending a huge amount of time on, figuring out the file structure, parsing files into objects, all of the sort of data munging stuff that people have to do before they can actually do something simple like make a plot. Okay, Hydroshare's Python client is called HS Client. It's a set of Python functions for interacting with Hydroshare. You can basically do everything via Python through the HS Client package that you can do as a user through the web user interface. So this includes creating resources, editing resources, interacting with resources in an interactive object-oriented way. And what that means is if you're developing a data science workflow, you can be pushing things into Hydroshare, pulling things out of Hydroshare to use in whatever analysis that you're doing in your programming environment. There's some example Jupyter notebooks in a Hydroshare resource that's at this link here. And of course, we're developing this Python package in GitHub. It's also in the Python package index, so you can just pip install it from there if you're interested in using this. Part of this Python package is this Python object data model where the structure of a Hydroshare resource is actually specified in this OAI ORE resource map document. And the client Python library translates that structure to a Python object representation. So it reads that structure, all of the metadata, puts it into a Python object. And then if it recognizes any of those known content types, it loads those known content types into a performant data object in Python. So for example, if you have time series in your resource and it recognizes them as time series, it loads them directly into a pandas data frame object so that you can actually manipulate it using pandas. You can save the structure, the whole structure of the resource back to Hydroshare if you've manipulated it. And of course, you can modify all of the metadata outside of Hydroshare and then send all of that stuff back to be ingested. And that allows you to have sort of this iterative way of working with things outside of Hydroshare if you're working in a programming environment. All right, it also allows us to extend the Hydroshare resource to that analysis environment. And as I said, it maps these common water-related data types to performant data structures in Python. We're actually working on this part of it right now, so this is not 100% complete. But our focus is loading and staging data for visualization and analysis using common Python tools. So we're not trying to reinvent all of the NumPy, scikit-learn, matplotlib, pandas, all of that kind of stuff, but rather getting the data into a format that then it can easily be used using these tools that already exist. Okay, behind the scenes, we've implemented the metadata models as Pydantic. We're using a technology called Pydantic. So this is just a set of classes that define all of the metadata associated with a Hydroshare resource. This is the enabling technology to make sure that we can load all of that metadata into Python objects that can be manipulated easily in Python. And again, some usage examples. I think I already talked about those. So basic operations, just as a quick example. So you can authenticate with Hydroshare. Hydroshare is using OAuth 2 for authentication. So we've got some options for how we actually do authentication. But then it's really pretty straightforward to create a new resource, modify the metadata elements, save it. You can delete a resource. We've got operations for files, metadata creation, all that sort of good stuff. So those are just some really quick examples. I talked about the data retrieval Python package. this allows us to access all of the data that's in USGS's National Water Information System. And I'll just mention this here, just if any of you didn't know about this. It's basically a Python mirror of the R data retrieval tool. So if you're working in R, there's an R data retrieval tool. If you're working in Python, there's now a Python data retrieval tool. And currently they both have mostly the same functions and pretty similar results. And we're collaborating with a guy at USGS named Timothy Hodson to make this happen. Again, there's some example Jupyter notebooks for how to use this in a Hydroshare resource. And it makes it really simple to go and get data from USGS. If you want to get daily streamflow data for a USGS streamflow gauge, you just pass in a site code, a parameter code, a date range, make one function call, and you get back a pandas data frame with all of the data that you just requested. So over here, you can see all of the functions available. You can get daily values, unit values, groundwater levels, site info, discharge, rating curves, like all of the stuff that's in NWIS, you can pull in with this package. Okay, so I described this workflow here. And over here on the right side, there's still some questions about how we re-execute the things that we share in Hydroshare. So this is where Tony is going to take off and start talking about some of the things that Kawazi is doing with linked Jupyter environments and some of the other tools that we have available. So Tony, I'll stop talking now, and you just, do you want to share your screen, or do you want me to just keep going here?
Yeah, maybe I should try sharing, because I'm looking at, there's a bunch of animations. It might be a little tricky.
Yeah, there's animations. I think it'd be easier for you to do it. So let me stop sharing.
All right, let's try this out. Okay. Let's see here. Do we see it? Slides?
Yes.
Yep.
Fantastic. Jeff, thanks for kind of leading all this effort. And I apologize for everyone. I'm a little bit under the weather, so it's probably not going to be my best presentation. Hopefully I'll get the point across. So yeah, I think what Jeff said, one of the things that Kwazi's been focusing on, myself specifically over the last few years, is how do we address that R component of the FAIR principles. So the reusability, but also reusability and reproducibility is another thing that we're kind of curious about, but also just generally, how do we extend the capabilities of Hydroshare in similar ways to what Jeff was mentioning earlier. So this is a slide that Jeff put together for me, but it's something that I'm sure many of us have seen this this image on the right before, that typically in order to reproduce some sort of findings or reuse someone else's work, we leverage a variety of different tools to help make the process easier, but it's still really complicated. And the big takeaway here is that there's no clear path that's always going to get you an environment that works. So we on the Hydroshare team, and I say we very broadly, some of my collaborators on the Hydroshare team have run into numerous problems, myself included, trying to create workflows that others can use easily. And even though we're doing research in this field, it's still incredibly difficult to make sure that to ensure that these things always work. However, we've been developing a variety of different tools to kind of address the problem in a variety of different programming languages. So just a quick overview. The ones that Kwazi is directly involved with is a Jupyter Hub instance. So this is a cloud implementation of Jupyter. It provides interactive notebooks in the cloud for any Hydroshare user. We've been tailoring this specifically towards research, or I'm sorry, education. Definitely addresses some research problems, but it's more suitable for, we found over time, it's more suitable for education. Our particular implementation is. We've used it in a number of classroom activities ranging from like 30 up to 100 plus concurrent users, as well as workshops. We've been able to tailor these environments, which we'll talk about in a minute, to address or to be kind of pre-configured for certain types of applications. So it is very customizable, but you kind of need to know who to talk to at Kwazi in order to customize it. There are some capabilities, or we allow some customization, like installing packages and persistent Jupyter or content environments, I'm sorry, and things like that. But any system level libraries are a little more complicated to get installed, or not, generally not accessible for most users. An extension of this work, or a similar idea, is what Shawin's team has been doing, which many of you are already familiar with, is CyberGIS Jupyter for water. And we try to align our efforts as much as possible so that we provide a consistent kind of user experience. But again, this is a Jupyter implementation, except it's deployed on, I believe, currently on Exceed, but it will be on a, I don't exactly, I think there's a new machine is being migrated to a new machine, and on you can you can clarify that. But anyway, it's in the, it's in the NSF funded cloud, and it does provide access to high performance computing. So now we're talking a little more research focused. So with these two efforts, we kind of deal with a large spectrum of use cases, which is pretty cool. Quasi's also been collaborating with MathWorks to host a MATLAB version. They call it MATLAB Online. It's essentially the same thing or very similar, but it runs MATLAB scripts and MATLAB live scripts. This is something that we are able to provide free to the Quasi community, which is fantastic. We don't see as much use of the MATLAB instance as we do with the Jupyter Hub. And then going, moving forward, trying to deal with this reusability aspect, we're exploring different technologies and efforts that are addressing the same problem, like Binder or Binder Hub and MyBinder. And this allows us to, allows the user to specifically define the environment that they need and to run their notebooks. Of course, this is limited in, if we use free services like MyBinder, it's limited in computing power. So the general workflow for interacting with these applications is described here. But actually, I should probably take a quick step back. A lot of these things are completely separate from the Hydroshare data repository, and I guess that's a kind of a key distinction to make. The Hydroshare is a data repository, and these are third-party or external applications that interact with Hydroshare through the API, the REST API, using tools such as the HS client that Jeff mentioned earlier. And that's actually pretty powerful because we can develop any number of external applications that can interface with Hydroshare directly. And the way that some of these computing environments work is you'll find your Jupyter notebook or your Hydroshare resource, which contains potentially some data and a notebook. And this is something that Jeff put together. And when you click this open with button, the top right corner identifies that, okay, well, this resource actually contains a notebook. It can be executed in a number of different environments. Where would you like to execute it? Now, this isn't a perfect system because, for instance, we see MATLAB Online. Well, MATLAB Online isn't really for Jupyter notebooks, but there's no reason why you can't analyze this data in MATLAB Online, right? So there's a little bit of a gray area, but for the most part, we see there's a Quasi Jupyter Hub and CyberGIS Jupyter for water. So if we were to click on one of those, we would be placed into one of these computing environments in the cloud. So now we're no longer in Hydroshare, we're somewhere else completely. And our data move over with us. And here we see it's at jupyterhub.quasi.org. So we're in the Quasi Jupyter Hub, and we have our data there, and we can open up our data and we can run our notebooks. Now, this assumes that all of the dependencies are installed. It's quite a large assumption. But we've been dealing with some things to address that. So just to cover the general workflow, we have, this is a similar example. We have a resource, we click the open with menu. What this will do is it will send a request to the respective third-party application saying, hey, I want an instance. The application will come back and say, okay, let's do some authentication. We use OAuth to handle this. So once it's verified that it's a real person and the person has permissions, an instance is created in the application, in this case, Jupyter Hub, and then Jupyter Hub will go back and say, hey, you said there's data, can I have it? Right, so they'll go ahead and request the data. Hydroshare will serve up the data, and then you're placed in your environment. So this kind of ping pong method, it doesn't use, I guess, another way of accomplishing a similar task would be you kind of maybe use a post request where we send all the data at once. In this case, what we do is we ask if we can have an instance. Once we're granted one, the third-party application goes back and says, can I have the data? So one key thing to note, which we'll address a bit later, is that we have data in two different locations now. We have Hydroshare data and we have data in Jupyter Hub. They are different from one another, or they could be the same initially, but they are in different locations and they can be out of sync. And I guess the grand scheme of thing, or the grand vision, is that we'd be able to publish that resource with a DOI, that capital P publish that Jeff mentioned earlier. And then we would always be able to reuse or reproduce the work published in Hydroshare. And we know that that's a little bit more difficult than it is to explain. So we use this pattern for a number of activities, like I mentioned, research and educational applications from Quasi's perspective. The research applications have been mainly focused at large workshop type events that we host, like the Summer Institute, or we co-host the Summer Institute in Tuscaloosa, Alabama, at the National Water Center, and also some projects like Water Hack Week, research oriented. But other than that, it's mainly for classroom exercises and conference workshops to demonstrate some sort of new tool or such. But just one example, we have this other service that allows us to extract domain data for the National Water Model. So we have a series of notebooks that walks users through, or students really, through obtaining the data, collecting forcing data and regrading it, and then running WRF Hydro or WRF Hydro configures National Water Model simulations. So what I mentioned before is that we have data in 2 different locations. This can be problematic. So it's definitely been a difficult concept for our community to understand. A lot of times we'll get help tickets saying, oh, I ran this thing in Hydroshare, and then they have some problem. And that indicates the first area of confusion is that we don't run things in Hydroshare. You're actually running them somewhere else. So it's not really a Hydroshare problem. It's someone else's problem if they're running it ran into issues. So that's just a really basic example that demonstrates that there's generally a confusion over where your data lives. And this is something we've dealt with for a really long time. Most recently, and actually this work goes back quite a ways. So the Olin College of Engineering had a senior project. We worked with them to kind of lay out how we might resolve this problem using a web app. And then this was actually worked on by 2 different people, Samya Purohit and then Austin Rainey. And now we're finally at a point where I think tomorrow or Thursday, there's going to be a newsletter announcement about this software, but it's been a very long process. But what we've developed is a plugin, a Jupyter Lab plugin, and you can see in the bottom right corner, in the red box, that is a graphical interface for visualizing your data in Hydroshare. And the point of this is not only so you can easily find and download data. A lot of people go directly to the compute instances after they're familiar with working with them. You don't necessarily have to go to Hydroshare every time you want to go to the compute instance. You might just go to CyberGS Jupyter for Water or Quasi Jupyter or whatever. So we want to provide an interface that allows them to see what data they have in their Jupyter Hub, what data they don't have, and what data is available to them. So here we're just looking at a variety of different data resources in Hydroshare, and you can click on one and download it. Once you download it, we have these these icons. They look like these little refresh symbols here. There's a series of icons that tell you whether things exist in Hydroshare, in Jupyter, and whether they're in sync or out of sync from one another, so you know if changes have been made. Again, I guess this is showing the same thing. You can click on your notebooks and run them, and then you can modify your notebooks and save your results back. So that's the general idea. That's going to be actually announced Thursday, but it's installed right now in this environment all the way down at the bottom called Jupyter Hub Minimal Base Image Beta. So we're testing it on our live site, but it will be installed in the Python standard Python v3.8 version at the top, and available on Thursday. So one of the problems that I mentioned earlier is making sure these environments have all the dependencies installed in them. It's a huge problem. And I think a lot of people on this call probably already are on the team, already know that this is a big challenge. One of the ways that we've addressed it is just by limiting or providing pre-configured environments for common use cases. So a general purpose Python environment, a general purpose R environment, and then we started experimenting with different specific environments. So on the Hydroshare project, we have this this modeling group that's focusing on the SUMA model. So we have an environment specifically designed for running SUMA, and similarly for WRF Hydro. But then we also have the CSUMS workbench and ModFlow workshop. So we've also been using our, this platform to prepare specific environments for individual events. The main reason for doing this is because a one-size-fits-all environment is really, really challenging, primarily because of software dependencies, and the size of the image gets really, really large. So we decided to break it apart. You know, Shaowen's team with a CyberJS Jupyter for Water are doing something similar with a kind of a different approach, but trying to achieve the same thing. It's really interesting what their approach is. One of the limitations with this approach is that you can only select from one of these, in this case, 7 environments to launch, when in theory, you should be able to launch whatever you want. It doesn't really matter. So that's maybe something we can work on in the future, but that's a limitation that the CyberJS Jupyter for Water, I think, overcomes it better than we do. But where we're going with this is, instead of us defining the environment, why don't we just let other people tell us how they're, you know, what are the dependencies for your workflow? You tell us, we can't read your mind. So what we implemented about a year ago was a connection between Hydroshare and mybinder.org. And it's actually a connection between Hydroshare and the underlying library or software called repo to Docker. So what repo to Docker does is it takes it's a workflow that goes through and builds an environment based on a directory of binder files that are found in some sort of repository, right? Such as GitHub. That's kind of where most of that work happens, or what most of the examples are around GitHub. Scott Black, a senior engineer at Quasi, formerly an engineer at USU, implemented a solution that would allow repo to Docker to do the same thing from Hydroshare. And because of that, if you go to mybinder.org, you can actually select from a Hydroshare resource, a Hydroshare resource ID. If there's a binder directory, it'll build a custom image or environment for you, stick you in it. If there is not a binder directory with your requirements defined in it, it will just build a standard default base image and stick you in it. Recently, we've been exploring how we can expand this work. So we presented a poster at AGU this year, kind of explored what other Hydroshare capabilities can be leveraged to make this experience a little bit better. One of the things we uncovered was that defining your requirements in these binder files does not guarantee you're always going to get the same workable environment. And there's a number of reasons for this. Something as simple as, if you're using an outdated or unsupported Linux distribution, the repositories or the software repositories might not exist anymore, right? That's a problem. If you don't define your library versions, that's another problem. Some of these are easy to fix, some are more difficult. So we decided that, or after a lot of thought, one way of dealing with this is just to archive the image in a container registry. If an organization like Quasi hosts our own container registry, which we do, we can archive these things and they don't ever have to be rebuilt again. They'll always exist. Now, the binder directory of files is still really important because it's essentially a README that tells you how you should be building the environment. But since we can't guarantee that's always going to work, we can guarantee that the image will always work if it was built once, as long as we don't delete it. So we came up with a solution that is not implemented. It's in theory, but we have a Jupyter. We have our Hydroshare resources already linked to Jupyter hubs or compute environments like binder hubs. We actually hosted our own binder hub more recently to overcome some of the limitations of mybinder.org, the hardware limitations. We have a container registry. So in theory, when we build these images, they will be stored in our Google, well, our stuff's running in Google, so Google Container Registry. And we can implement some sort of a method so that to ensure that certain images aren't removed after maybe a resource is published. So it's archived the image as well. We can even export that image as a tar file or zip, whatever, as a file and drop it back into the resource. So you can actually have the image as well, or this could be hosted somewhere else that could be downloaded potentially. So we can really kind of close that gap in the reusability of the resources published in Hydroshare. We also started exploring how we might be able to leverage resource aggregations to provide insight into what actually is being installed in these binder files. That could be a way for us to not just visualize, but edit them and things right in the Hydroshare interface. In this example, I'm just using metadata, file-based metadata to populate this, but there's no reason why we can't have a binder aggregation that helps us validate if something is a valid binder or not. And then moreover, we started exploring how we might build a third-party application to launch your binder aggregation to visualize it, edit it, and do some other validation and checking and things like that. Really, part of the problem we've noticed is that there's a cyber infrastructure challenge, and there are solutions. There's a variety of solutions, and we have to find the right path or the right set of paths to solve the problem. But there's another huge area that's missing, which is community education. How do you show people or tell them or somehow demonstrate or encourage them to learn what it means to make something reusable or reproducible? Some field scientists that maybe are analyzing their data using Jupyter may not know anything about, software repositories and Linux distributions and binder and all of that. So somehow we need to provide guidance and empower them to help us create these reusable environments. So with that, I'm going to pass it back to Jeff, unless this slide was just left in there nice.
No, I mean, I think this is a nice summary. I mean, I think we as a group need to be thinking about what it means for computational science to be reproducible. And of course, one of the problems that we are well familiar with is how we're going to link all of these pieces together. And of course, how to build shared access to data and computation, and the challenges associated with, well, what happens when the data get large and what happens when the computation gets large. Some of these workflows that Tony and I have talked about today start to break down because either it's too hard to move the data or we don't have enough power behind the computational resources that we're giving people. And so while a lot of these tools are really awesome and we're starting to make a lot of the connections, it's not going to work for all of the use cases that I think we're going to think about on this project. So that gets at how do we provide the right computational environment and how do we get people to understand what the right computational environment is. And then as Tony talked about, like what the challenges associated with maintaining those things over time are not trivial. And of course, platform and library dependencies. Those are all considerations for the types of work that Tony and I have described. And Tony, apologies, I modified that last slide with questions to put both of us on there. I think the version you have probably only has my name on it. So
that's
just
okay.
kill the PowerPoint there, and we're all good to go with questions.
I was looking at my other screen and I said, oh, I still have the questions with Jeff. I was like, okay, I'll just stop.
That's okay. That's okay. As long as you don't like take off right now, that's totally fine.
No.
Yeah, that's great, I guess, Jeff and Tony. I think that covered a lot of things that were in Hydroshare, and it put all of the things together, which is good to see everything in one place. And I think the last slide that you showed is really pertinent to what we as a team have to be thinking about. Like, yeah, so I think that's really well done. So any questions from others on the call in terms of Hydroshare and the resources and the capabilities there?
I'll start asking a question to break the ice. Again, thanks very much for doing this, very helpful. The question I have is what iGuide could do to make Hydroshare better and get the Hydro community more empowered.
I'm not sure how to answer that question yet, Shaolin. I think we're still dealing with a community that is struggling with a lot of these concepts that Tony and I have talked about today at a really base level. And a lot of people have not elevated their work to, I'm going to say to the level of sophistication and computation and integration that is going to be necessary for a project like iGuide. And so, as Tony said, I think there's a lot of work to be done in showing the community of people how using these sorts of tools and working in this kind of a way can really elevate their science and make it more reproducible and also enable new things that you couldn't do before. And so if there are these specific user personas, use cases, and the particular applications that we're going to be working on for iGuide that we can work through and show how these tools actually work in a way that's sort of transparent to a wider group of people than just the people sitting on this call. Because I suspect most of the people on this call were like, oh yeah, I've seen that, I've seen that, I've seen that. I know totally what you guys are talking about. But if you got a bunch of hydrologists in the room, they'd be like, whoa, you know? So I think one thing that iGuide can do is really focus on how the cyber infrastructure can enable the science and demonstrate it in a way that we can communicate it to this broader community of people that could benefit from the platform that we're building. I don't know, Tony, if you have any additional thoughts.
No, I don't. I was actually thinking that's a really tough question.
Yeah, it is. It's a hard question. And I think it goes beyond Hydroshare too, Shaowen, because I mean, Hydroshare, Tony and I showed a lot of integrated pieces today that show Hydroshare is kind of it's more than just a repository, but of course it's not the solution to all of the problems that we need to solve with iGuide. And so it's one of the pieces in the puzzle that we need to put together. But that question, obviously, Shaowen, goes across all of the pieces that we've seen so far.
So I guess I would just add one little bit, which I think you already touched on, Jeff, is that you know, a lot of what we're talking about with Hydroshare and the cloud computing and all of that, they're all it's low-hanging fruit. These are the easy set of problems or use cases. And as soon as we start dealing with large amounts of data, which, you know, Drew's on the call, you know, we start dabbling with national water model, retrospective data, which is still small in comparison to some other problems. Things get really difficult. And then it's not that there's not cyber infrastructure solutions, but it gets that much more difficult for people to actually, like, it's easy for us to understand, or it's cool, right? We think it's cool, but other people, it's just, I think for a large part of the community, it's even further above their heads. So if we have a challenge of, you know, trying to explain the best practices for some of these kind of smaller types or easier use cases, how do we do it when we have to use, you know, cloud native data and we have to run, you have to run using MPI? And I mean, these are some of the problems your team has addressed with CyberGS Jupyter for water, and it just gets that much more complicated, but that's the direction that we're going in. And I think iGuide could hopefully provide some guidance for that kind of realm, but there's a huge outreach component that needs, like, there's a huge effort that has to happen to really bring everybody up to speed and at least simplify things down to the point that if you are just a pure scientist, you're a pure hydrologist, you don't need to know all the intricacies of how this all works, but you do need to know how to do it to some extent, right? How do you leverage these capabilities? And I don't really know how, but I feel like I'm hoping that I can help us solve that problem. But the problems are only going to get more difficult from here.
The good news is we got a work to do.
Yeah.
But I think what you presented is really nice in terms of the other angle we have learned throughout this call this morning. That is, there's a tons of nice capabilities and features already established by Hydroshare. We could leverage, right? As we go forward, we would need to remember not to reinvent the wheels and take advantage of what has been learned and what has been established as we go forward. But I think Jeff presented a very nice slide. You know, this user sits in the middle, and there are a bunch of things around the user, and then you need to interconnect all these pieces. And hopefully, based on what Tony said, the users actually will not need to know all the intricacies of linking all these pieces together. And so how do we do that, right? So that problem is bigger than what a Hydroshare and other sort of equivalent cyber infrastructure capabilities, sort of community tailored cyber infrastructure communities currently are addressing. So the question for us here is how do we tackle that puzzle together, sort of given the scale of iGUI's focus.
Yeah. Any other quick questions? I apologize. I have to run another call in like 4 minutes. So I unfortunately am going to have to bail, but yeah, you know where to find me. So
Any quick questions for Jeff or Tony? Jeff, Tony, can you share the slides with me? Send it to me on Slack, or and then I can post it as well. So we are getting a collection.
yeah,
of
I'll
all
make
these.
sure you get them. And I've got a combined version that I put together, the final version of Tony's slides and my slides, and I'll make sure you get that today.
Thank you.
Thanks, Jeff.
Yeah.
Okay, I guess so. Maybe we'll move on the last couple minutes. Kind of try to decide our plans for the next maybe meeting. So first things first, I guess, are we all, at least on the call, okay with this time? Because the new semester is starting, and I guess, yeah. Okay, so I see no objection. So we'll continue with this time unless we really have some conflict from someone. The second thing is, I guess, in terms of the next couple of weeks, I think in the next few weeks, we would want to maybe hear from others as well who have not shared their capabilities. I think Steve, maybe you're one of the few people who's left. So would you be able to do that maybe in the next meeting? Okay. So next, I guess next Tuesday on the 18th, we'll have Steve present.
Yeah, and it'll be shorter. It's a little less, frankly, a little less exciting computationally speaking than the other stuff that's going on here. So it's probably only going to take me like 20 minutes. So
that's good, but it will give us a new angle in terms of ABM and things like that, which we have not covered. So it would be good.
Sure.
So I think we'll do that next week, and I'll touch base with Carol after I guess she's out of her thick of things with the NSF review, and then plan for the weeks after that. But my thought is we'll focus mainly on getting some of the design stuff done, as well as the user personas, and maybe focus our meetings more on the technical day-to-day progress kind of things, and sharing kind of updates of what we have been doing. Yeah, so that's all I have. Any other kind of last minute things or any other business we should know of? Okay, hearing none, I guess I move to adjourn this meeting, and thank you, Jeff and Tony, for your nice presentation, and we'll meet back next week.
Good. Thanks.
Thank you.
Thanks, bye, bro.
Bye.
Take care.